Assalamualaikum warahmatullahi wabarakatuh. My name is Akil Afison Longtian. Number metric 2019293238. And today I'm gonna explain about uh, thermofluid labs for MEC294 lab sheet 4, which is two shaft gas turbine simulator. Problem statement: by using the two shaft gas turbine simulator, student needs to explore basic understanding of the functioning of a gas turbine. Start the observation when following parameters are changed: point overall system efficiency, rotation speed of high pressure turbine, rotation speed of light low pressure turbine, torque and power that generated by two shaft gas turbine simulator. First, change pressure ratio from 4 to 10, increment of 1. And number 2, change a lot on power turbine from 30% to 100%, increment of 10%. Number 3, change gas generator high pressure turbine efficiency from 60% to 100%, increment of 10%. Number 4, change power turbine efficiency low pressure turbine from 60% to 100%, increment of 10%.
Microsoft Excel is used to make the table and the graph. This is the sample calculation to find the theoretical value for thermal efficiency. Referring to graph 1, we can see that the thermal efficiency for experimental value is higher than the theoretical value, and it is certain that the relationship between the thermal efficiency and pressure ratio is directly proportional to each other. This occurs due to the abundant amount of gas being compressed in the compressor and as the pressure increases, allowing more motion of the shaft. Therefore, there will be lesser, resulting in the increase of thermal efficiency. Based on graph 2, it shows a slight increasement on the power generated from 30% till 50% of load. As the power reaches 60%, a steady decrement till it reaches 100%. The power generated is at 0.1 kilowatt at 100%. The higher the percentage of the load, the lesser the power generated needed. Graph 3 shows that the relationship of the thermal efficiency and gas generator high pressure efficiency is directly proportional. As plotted in the graph above, the gas generator efficiency kickstart at 60% with the thermal efficiency of 1.61%. As the efficiency of gas generator steadily increases to 100%, the thermal efficiency reaches its maximum efficiency at 1.73%. This occurs a more net output transfer to the low pressure turbine. The higher the efficiency of high pressure in high pressure turbine, this lead a more spinning of the shaft and resulting to the increase of efficiency of turbine. Referring to graph 4, it shows that the relationship between the thermal efficiency and a power turbine, a low pressure turbine efficiency, is decreasing linearly. As plotted in the graph, it also shows that the thermal efficiency continuously drop as the efficiency of a power turbine, low pressure turbine increases. At 60% of a power turbine efficiency, the thermal efficiency is at 1.61%. The continuous drop of the thermal efficiency could be seen as it reaches a negative value of negative 1.18% at 100% of a power efficiency turbine.
As you can see, the graph above shows comparison between the third and fourth graph. It is apparent that these two graphs have different slopes. In graph 3, the gradient between the thermal efficiency and gas generator efficiency has a positive slope, whereas in graph 4, the gradient between thermal efficiency and power turbine efficiency has a negative slope because as the power turbine efficiency increases, the thermal efficiency also decreases as well. For the advantages of two-shaft gas turbine, the choice of whether to use a single shaft or two-shaft gas turbine is largely determined by the characteristics of the driven load. If the load speed is constant as in the case of an electric generator, single shaft unit is often specified. An engine is specially designed for electric power generation would make use of a single shaft configuration. An alternative, however, is the use of a two-shaft engine if the load needs to be driven with a varying speed. Two-shaft engines are advantageous. The advantages of a two-shaft gas turbine are that compressor and high pressure turbine are driven at optimal speed for the respective power. Speed or torque at the power turbine can be adapted and optimized to the respective drive function. Vehicles require a variable speed, whereas a synchronous generator needs a constant speed. Thank you for watching.